Okay, what is the answer for this? Answer is they are looking for the easiest way. So answer is D. You need me to explain why A cannot? So if they are looking for the easiest way, means they are looking for the largest moment. They are looking for the largest moment created by the same force. Because to be fair, F must be the same, right? So moment equals to force times perpendicular distance. If my force is going to be the same and I want the largest moment, that means my perpendicular distance of the line of action of the force to the pivot must be the largest. Okay? So in this case, you have to sort of visualize how this thing will turn when the force is applied. That means you need to find out where the pivot is. Yes. Why not A? Yeah, I'm going through the background concept first. That means you need to know where is the largest perpendicular distance. Because F is the same throughout. So if I'm looking for the largest moment, my perpendicular distance must be the largest. That means you must be able to determine where the pivot is. So you have to imagine if A is being subjected to a force like that, how will it rotate? Where will the pivot be? Okay, so after identifying where's the pivot, right, you need to draw your line of action of the force. So for A, I'll use a blue color, right? So can you tell me where's the line of action of the line of action of the force is the dotted line. You extend front and back, and then where is the perpendicular distance? The shortest distance from the line to the point. Yes. Okay, so we just keep in mind that this is the perpendicular distance. Who don't know how to obtain this perpendicular distance? Who needs me to go through again? Okay. Okay, then. There's no moment. Wait. Where do you think the pivot is going to be if it's subjected to a force of F? Most likely here, right? Okay. Then, if this is the pivot, the line of action of the force has already been drawn for you. So, this is the perpendicular distance. And since I'm looking for the largest perpendicular distance, B is out. Yes. For which one? A, B, C, or D? It will be a clockwise movement. Yes. How about C? C is pretty obvious, right? C's perpendicular distance will be this. Yes? So far, which one is largest? A, B, or C? A is out already. Because A is, this side is actually the hypotenuse. Do you see a right angle triangle? This is the hypotenuse. And this is that side. It's not hypotenuse. So it must be shorter than the hypotenuse. So the perpendicular distance is shorter than the hypotenuse. But for D, this is the perpendicular distance. So it is actually longer than perpendicular distance of A. Therefore, I eliminate A. Now left with C and D. So for D, again, you need to visualize or have an idea where is the pivot. It's going to be here, isn't it? And again, like, is the line of action of the force drawn for you? No, we have to actually extend the force. Okay, extend the force. So for all you know, this extending of the line of the force, right, may help you to determine the perpendicular distance. And that will help you in your exam. So where's my perpendicular distance? Over here. Yes? And again, this is the hypotenuse versus the green color. So D is the correct answer. Are we okay? Very quickly, we try question 14. Answer is B. Center of gravity rises. Okay? Next one, we did this sort of in our notes, but in this case, there's a resultant moment. So can you all try to calculate what is the resultant moment? So step 1 is this, given. Step 2, okay, so you follow the color. Step 3, the most difficult one, finding perpendicular distance. So 2 meters, this one is 2 meters, this one is 3 meters. Then now step 4, green color. Step 5, finding the direction. Okay, then lastly, okay, so because they tell us that there's resultant moment, therefore there cannot be, and there's no zero value. Look at the options, there's no zero value. So we have to sum up all the anti-clockwise versus the clockwise. Clockwise is 60. So answer is A.